Hello, this is Mr. Stansbury. I'm going to take you through the notes on justifying statements. At the end of this, you should be able to say, I can use definitions, properties, postulates, and theorems to justify statements, and I can write two-column proofs to prove theorems about lines and angles. Okay, so first thing is let's talk about what definition, property, postulate, and theorem means. Okay, so definition is just an exact meaning. That's something that we've defined. And I'm going to give you a bunch of examples here in a minute of all of these. A property is just rules that we use, like math rules. Okay. Postulate is a statement that's accepted without actually having it being proved yet, but we just say that, yeah, that works. Okay. And then theorem is a statement or conjecture that has been proven. Okay. So let's look at some examples of each of those. Okay. Definitions, properties, postulates, and theorems. So definitions, like some examples of definitions that we've talked about so far: midpoint, angle bisector, complementary and supplementary angles. These are all definitions that we can use to prove things. Okay, no need to write all these down. This is just to kind of help you understand what each one of these things means. Okay, so don't write all this stuff down. Okay, properties. The addition property, subtraction property, multiplication, division, all of these things here, these are all the properties. And we used these earlier to go through and solve algebraic proofs, right? These were all of our reasons that we were able to do our algebra, okay? Postulates. Let's see, we've got the ruler postulate, which means we can measure something and say that it's exactly this long. Protractor postulate, same thing, we can measure something to see what an angle is. Segment addition postulate. So these again are all things that we accept as true but haven't officially been proven yet, but we just say, yeah, these work. Okay, and then we also have theorems. Okay, and this is what we're going to start getting into a little bit more. So these should not look as familiar, but they'll start looking familiar pretty soon. But vertical angles theorem, right angles theorem. One of the theorems that might sound familiar would be Pythagorean Theorem. Okay, and again, these are all things that have been proven. Okay. All right. Some of the properties that we haven't really talked about too much. We talked about addition, multiplication, subtraction, and division. But some other important properties are reflexive property. Okay, so for all real numbers A equals A. Okay, so basically we can say that A is the same thing as A. That's the reflexive property. And I'll show you how to use these things here in the coming up sections as we go through them. Okay, symmetric property, we actually used this earlier in class. If A equals B, then we can say B equals A. Okay, so here's where the meat of each of these property come up. Okay. So, and then in the transitive property we have, if A equals B and then B equals C, that means that A has to equal C as well. Okay, and that's the transitive property. And again, we'll take a look at these in context here pretty quick. So let's look at an example here. Name the property, postulate, or definition that justifies each statement. Okay, and we've got this picture to go with it here. So this one here says, if angle ABE is a right angle, then that means that measure of ABE has to be a 90-degree angle, right? And that is stuff that we've talked about before. That's just the definition of a right angle, right? So we would just write in definition of a right angle for that. Okay, now it says if angle 2 is congruent to angle 1, so they're saying if these two are congruent and angle 1 is congruent to angle 5, then that means angle 2 has to be congruent to angle 5. Okay, and that is one we just talked about on the previous page here. This is the reflexive, because if 2 is equal to 1 and 1 is equal to 5, see how the 1's are the same here? That means that 2 also has to be congruent to 5. Okay? So again, that's just the transitive property. Okay, for C, given that B is the midpoint of AC, so here's AC, and they say that B here is the midpoint. prove that segment AB is congruent to BC. And again, this is stuff that we've talked about in class as well. This is just simply the definition of the midpoint, right? So we would just write down in that definition of a midpoint because it says that it's the midpoint of AC. Okay? D, measure of angle 2 plus the measure of angle ABE, so these two angles here, has to equal the measure of DBE. And this is one that we briefly talked about in the previous notes, and this is our angle addition postulate. Okay, so we will just write that one in there. So it says if we take measure of angle 2, so if we add this angle to this angle, that's going to equal this whole angle here. Okay, that's angle addition postulate. Okay, and you do not have to memorize all of these. We will, we'll have ways of making sure that you have a list of these so that you can look at those. Okay. Right now we're just trying to see if we can figure out what's going on with these. Okay. E, if angle 1 is supplementary to FBG, so angle 1 is supplementary to, let's see, FBG. So they're saying this angle here and these two, this whole big angle here is supplementary, meaning it adds up to 180, right? Then the measure of angle 1 plus measure of angle FBG equals 180 degrees. And that's from earlier in our unit, which was our definition of supplementary angles, right? So it's just something that we had defined and we're able to use as a definition in here. Okay, so this is the this is really like early stages of doing our own proofs and theorems, using theorems and postulates to prove things. Okay. All right, let's take a look at one other example. Okay, so another example using the diagram from the previous page, the same diagram here. Name the property, postulate, or definition that justifies each statement. Okay, so EB plus BG, so EB plus BG equals EG. Right, and we've taken a look at that before. That is our segment addition postulate. So we add one piece of a segment, add it to the other piece, and it's going to equal the two pieces put together. Okay, segment addition postulate. All right, B, if angle 5 is congruent to angle 6, so 5 and 6 are congruent, they're saying, then BF, where's B? There's BF bisects angle EBC. So since this is the same as this bisects this, right? And we've talked about that. That's our definition of an angle bisector. Okay, cuts the angle exactly in half. Okay, if measure of angle 1 plus the measure of angle 6 is 90, so 1 plus 6, if those together equal 90, then angle 1 is complementary to angle 6. Okay, and then hopefully that complementary word right there should help us out, just the definition of complementary angles. All right, for D, if measure of angle 1 plus measure of angle 5, 1 and 5, equals the measure of angle 6 plus the measure of angle 5, then that means the measure of angle 1 has to equal the measure of angle 6. Okay, and that's basically just taking these two things and subtracting each one. So if we subtract the measure of angle 5 from both sides, if you look at that, we just take that out and take that out, subtract those from both sides, you are left with measure of angle 1 equals measure of angle 6. Okay, it looks like it's close to the transitive property, but transitive is saying if one thing is congruent to another, and another is congruent to the other, a different thing, then the first is congruent to the last. So anyway, we subtracted 5 from both sides, subtraction property. All right, and then let's see this last one here. Given that line AC is perpendicular to line EG, so AC is perpendicular to EG, prove that triangle ABG is a right angle. Okay, and so that's just our perpendicular lines. So again, like there's lots of clues in here. So look, we've got this bisects EBC, definition of an, and it's a ray that's bisecting an angle, definition of angle bisector. This right here, complementary angles, definition of complementary angles. This is we're taking a segment and adding it to another segment and adding them together, segment addition postulate. Okay, and then here's our little perpendicular piece here. This line is perpendicular to this line. Show that that makes a right angle. That's our definition of perpendicular lines. Okay, so that's all there is for this one here. If you have any further questions, please ask in class. Thank you.